Hello friends, we are going to start lecture series of DP900 Microsoft Azure Fundamental Exam. As per current syllabus covering all the modules of Azure Data Fundamentals, it has 4 sub-modules. First module is Explore Core Data Concept. Its weightage is 15 to 20% in the exam. Second topic is Explore Relational Data in Azure. Its weightage is about 25 to 30% in exam. Third topic is Explore Non-relational Data in Azure. Its weightage is also 25 to 30%. And last topic is Explore Modern Data Warehouse Analytics. Its overall weightage is 25 to 30%. Total passing marks is 700. There is no negative marking in the exam. So in module 1, Explore Core Data Concepts, we are going to cover Explore Core Data Concepts, Explore Data Role and Services. Second module, wherein we will cover Explore Fundamental Relational Data Concepts, Explore Relational Data Services in Azure. Third module, which is related to non-relational data in Azure. So we will cover as Explore Azure Storage for Non-relational Data and Fundamentals of Azure Cosmos DB. In fourth module, Explore Modern Data Warehouse Analytics, wherein we will cover Explore Fundamentals of Modern Data Warehousing, Fundamentals of Real-Time Analytics, Fundamentals of Data Visualization. This is as per the Microsoft course material given for DP900 exam. So we will cover each lesson one by one to cover all the modules. So let's start with first module, that is Explore Core Data Concept. In this further parts, we will cover identify data formats, file storage, databases, transactional data processing, and analytical data processing. So if you see in fundamentals, this complete module is basically based on basics of Azure data. So if you see, data is very important nowadays. So we can see that everywhere we are generating data. So whether it's mobile, we are using mobile applications, WhatsApp, Facebook, then LinkedIn, whatever applications we are using, everywhere you can see in the backend we are storing data. So everything is based on the data. If we are saving some numbers in mobile, that is again data. We are sending some messages to someone, again that is data. And we never want that our data is lost somehow, right? So this data is very important, and it should be properly stored, properly available, and always available. So these are the key things which every user want. So since data is everywhere, so there must be some structure or some format of the data needs to be there, right? Data is easy to collect because every application, everywhere we are using data. So when we talk about data, then few things comes here. What would be the format of data, where to store the data, how to access the data, what should be performance of data, and what all solutions we need to have to better processing of the data. So these all things comes into the mind. So if you see that data is very easy to get, to collect from different applications, it's cheaper as well to store, and also it needs to be accessible to everywhere for the business perspective. That is important. And for data solutions, it includes lots of processing needs to be there, lots of analysis, and all the different softwares, different services in Azure are available to process the data, right? So if we see that in our competitive market, data is the useful asset and valuable asset, and this is the uh, main thing to analyze something, or to check how the business is going, how the growth is going, how to do prediction of the future. So everything is based on the data. So now we should have that capability to capture, store, and analyze the data effectively and efficiently, right? So this is the overall introduction. Now coming to data, what is data actually? If you talk about data, so data can be related to anything. Like for example, if suppose students are going to school, right? So school details, like how many classes are there, how many students are there, how many teachers are there, what all course material is there, what all books needs to be there, right? So all these are data. So data is, if we talk about data, data is a collection of facts, numbers, objects stored in structured, semi-structured, or unstructured way. So these three are formats. If you see, structured, semi-structured, or unstructured way, it means data, whatever data it is, how it's stored, in which format it's stored, it's all about data. So data structured in which data is organized represent entity. Like for example, if we talked about student data, school data, it's entity. Similarly, we can take other examples, like suppose we are selling some products. So products is a data, customer is a data, sales is a data, and all are entities, right? So each entity typically has one or more attributes, right? Attributes, or we can say characteristics. For example, if we talk about customer, so what are attributes? Name, address, phone number. If we talk about say school, what all attributes are there? Classes, like if we talk about classes, what is the class name? How many sections are there, right? How many students are there? So all these are attributes, all these are characteristics. So if we talk about like it can be any type of entities there, and its attributes, or maybe we can say whatever we have stored, that is called as attributes, right? So every entity is having attribute. Now let's talk about the different formats of data: structured, semi-structured, and unstructured. Structured data, its name says that structured data, it's proper formatted data. So structured data means data which is having some schema in the sense of rows, columns, right? Wherein we have fields, or we can say properties. Like for example, if you see this structured data, so one example we have for customer and product. So this is structured data in rows and columns form. ID, first name, last name, these are the properties, fields. So schema of structured data is tabular, right? So this data is represented in one or more tables that consist of rows, and row represents each instance of entity, and column represents attributes of entity. So this one row, like Joe, this is having details of one person, right? And these are first name, last name, email address. These are the attributes. So if you see that this table itself indicates that first is customer, second is the product, right? So this is properly structured data, and having, we can understand this data very easily, right? So it can have multiple tables, multiple, but whatever multiple tables are there, there is some relation between the tables, right? For example, we have this customer and product, so there must be some relation between the tables. That relation is helpful to understand that, or need to have more structured or normalized data. We can understand later on what is normalization. So if you see that how to make that relational model, by having some key related to both the tables, right? So through that we can have the structured data. So let's look into the semi-structured data. What is semi-structured data? Its name says that semi-structured means not completely structured, but some part is structured. So this has structure like wherein we have a variation between the entity instances, right? For example, so for example, we have customers, right? Customer have email address or multiple email addresses, and some may have no email address. So there is one common format we generally use for semi-structured data, which is JSON format. JSON format, its full form is JavaScript Object Notation. So this is very commonly used as a semi-structured format. So in this format, if you see, there is one just image has been added here. So it indicates that customer name is Joe Jones, right? And addresses can be multiple. In that case, it may have multiple addresses, right? So this is not exactly structured as a tabular structure, but semi-structured. We can understand this data by looking into this JSON file, right? So each customer is having address, contact information, right? All the fields are there. So this is called as semi-structured data. So if you see that this is JSON format, we can have in other format as well, for semi-structured data. Next, coming to unstructured data. So unstructured data comes, it's not structured. Unstructured means it's not structured, and if we see that not even semi-structured. So like for example, any image, any audio video files, or any kind of unstructured document, word document, or any kind of document, or maybe binary files, all those are unstructured data. They don't have any structure anywhere, right? So such type of files are known as unstructured, and we just store those files in Azure and utilize for processing perspective wherever required. So these are the three different formats which we generally use to store the data. So next, coming to data stores. So whenever we have data, we need to store this data somewhere, right? And what type of data can be there? Either file store or databases. So two broad categories we have for data stores. Now, files can be stored in local file system on local computer, or in some removable media, like for example USB drives, wherein we have to just store data into drives, and we have to just take drives along with us whenever we are going somewhere, and so that we can take data out of that. Central storage location is the third option, which is nothing but cloud. So best part is, like, if we store data into cloud, then we can access it from anywhere. And if data is stored or file is stored in the local computer, so we have to always keep that computer or that laptop along with us, wherein file is stored, right? And second option, for USB drives, you have to keep your you have to take USB drives along with you to access the data. Third option, cloud, means it can be accessed from anywhere. That is the benefit of storing data into cloud, which is the central storage location. So when we talk about data, so in different organizations, based on the required, we see like where we need to store the data, whether it needs to be in so local computer or in the cloud. So it all depends upon the overall requirement, how to access the data, from where we need to access the data. Then cost is there, security is there, reliability is there. So all the parameters are there. Based on that, we decide in the organizations like where we need to store the data. So next part coming, like, data store is fine, we need to store data, that is fine. Then third part is what should be the what type of format we need to have for data, right? So as we discussed in last slide, that formats can be three types of formats: structured, semi-structured, and unstructured data, unstructured format. Right now, whatever application and services we are using, that need to either what type of rights we need to have to access the data, read, write, and process the data. Based on that, security related things, or all the access related things need to manage. Next point is, when we have different formats of the data, then also we need to take care of how to access that data. If suppose we are storing data into tabular format, so we can keep it into the database and then access it from the database. Database can be Azure, SQL, or any database. So need and how to process, how to use the data, that complete architecture we build based on the overall data access, data processing, and different kinds of requirements. So need for data files to be readable by humans or optimized for efficient storage and better processing. So next, coming to different file formats. So first file format is comma separated format, which is delimited text files, wherein we have different attributes with comma separated. For example, in this example, first name, last name, email, which is comma separated, and one complete row. If you see Joe, Jones, this is all entirely comma separated row. This is called as comma delimited format, or delimited text file, CSV file. um, so this format is one type of file, document file. Second is JSON. JSON is a very popular format. In JSON format, we have hierarchical document structure, like hierarchical document schema, we can say. It's having different data entities, like customers is the overall entity, and it has different attributes. For example, first name, last name, contact, and within the attributes we have comma separated. Attributes are separating with comma. Each attribute may have further collection of objects. For example, in contact we have type, number, and it can be having multiple contacts as well. So this is the flexible format, which is good for both structured and semi-structured, and it's easy to access, easy to process, and even in fact we can say fast processing as well. So each, if you see in this particular example, each customer has three different attributes, right? And contact attribute is having collection of objects. So all the things covered here, which is object like type, home, number, and then its number, it's kind of key value pair, name value pair, which is again separated by comma. Third format is XML format, which is given here for the customer only. So for example, customer name Joe, last name. So you can see its format, like under customers there is first customer wherein name and then last name added here. So this is kind of human readable data format, which was popular in 1990 and 2000s. It's largely, if you see that this is almost less verbose format of JSON, and this particular format has some tags, and tags opening and closing or closure of that tag, and within that value is there. And if you see that customer name, these are again attributes, name, last name, these are attributes, and contact details, like for example we have multiple contacts, so contact details, opening and closing of tag, then within that contact type and number is the attribute. So these are the attributes here. So next, coming to blob files. So all the files are stored as binary data, like ones and zeros data, but in human readable format. So those like bytes of binary data are mapped into the characters, like ASCII characters or Unicode characters. That is binary large objects. Such type of formats we store here, and it can have like videos, audios, application specific documents, where in internally it store binary data, raw binary data. So common type of data, wherein for example if suppose some applications wherein we have lots of images, lots of videos, audios, we store using this blob files, and um, we can store it in Azure as well. So when working with this type of data, so professionals refer to this data as blobs. So if you see, full form of blob is binary large object. So next, coming to optimized file formats. So optimized file formats are called as, like for example, the file formats which we read earlier, like for example structured and semi-structured, those are very useful, but those are not typically optimized for storage space or processing perspective. So like over the time, like if we see that there are few optimizations required, for example compression, indexing, and efficient storage, fast processing. So for that perspective, few file formats have been identified as optimized file formats. So those are three major file formats, like Avro, ORC, and Parquet files. So let's look into like what are the different features or different benefits of each file format. Like for example, Avro. Avro is row-based format, and it was created by Apache. So each record in this contains header and data, and a header, and we can say description of data, wherein we can call that data as a record. So this header is stored as JSON, and data is stored as binary data. So if you see that it's a combination of both, right? So this is very good format for compressing data and minimizing storage and network bandwidth requirements. So if you have if you are concerned about like network bandwidth requirement, or maybe we need to minimize the store compressing the data, so in that case we choose Avro format. Second format is ORC. Its full form is optimized row columnar format. So this organizes data into columns rather than rows, and it was even developed by Hortonworks. This is for optimizing read and write operation in Apache Hive. So Hive, I think we will cover later on in upcoming sessions. Hive is a data warehouse system which supports fast data summarization and querying over large data sets. And so if you look into this format, this is a type of like stripes of data. It contains stripes of data, and each stripe holds the data for column or set of columns. So each stripe contains index into rows in the stripe. So this is for fast reading the data, fast reading or searching the data. So data for each row and a footer that holds statistical information, like for example count, sum, maximum, minimum, such type of information it shows in the footer. So so this is overall ORC format, wherein if suppose we need to store the data into columnar format, right? And suppose we need more details in at the end, so in such kind of scenarios we use ORC format. Then third format is Parquet format, and this is another columnar data format, and it was created by Cloudera and Twitter. So this file contains row groups. Data for each column is stored together in the same row group, right? So for one column, it's stored in the row group. So each row group contains one or more chunks of data. And if you see that Parquet file includes metadata, and that metadata describes set of rows found in each chunk. So an application can use this metadata to quickly search the data, quickly locate the correct chunk for given set of rows. So for searching perspective, this is very good for fast searching, and it retrieves the data in a specified column for these rows. So Parquet specializes in storing and processing nested data type efficiently, and it supports very efficient compression and encoding schemes. Mostly if you see for better processing, better searching, better fast searching for nested data, if we have requirement of nesting data, in that case we use Parquet file. Okay, so next is relational databases. So we know that whenever we have structured data, so in that case structured data is having some schema, and we store that data into the row column format, that is in the tabular format, if we can say. So in such kind of scenarios, like relational database is wherein we have a relation between two tables, right? And so table is having some entities, like for example customer, product, order, these are the entities, right? And within the entities we have different attributes. So for example, if suppose we have table customer table, so within that table we have two email IDs, right? Two addresses are there, we are showing into this image. So how to identify these rows as unique? So for that we need to have one ID, that is the customer ID. Now this customer ID, how do we ensure that it should not be taking any duplicate values? Maybe we have to add some check, or maybe some constraint we have to add, and that constraint is primary key. Primary key means we cannot update null value, or we cannot update duplicate value. Like for example, email or maybe other columns may have same value, but ID cannot be same. In ID every time it would be having different value, otherwise it will give error. So primary key, its benefit is that primary key is used to have that uniqueness, and secondly we can create relationship with the other table. For example, in this image, if you see, customer is the ID is the primary key here, but now in order table, order number would need to be ID, sorry, primary key. Now how do we relate that which customer has initiated this order, 1000 order? So in that case we have to make relation between customer and order table. So one customer ID would be there, one, and this customer ID needs to be foreign key of this customer ID of customer table, right? So in one table this is primary key, and in child table, or we can say in this related table, it would be foreign key. This way we make a relationship between different tables. Similarly, in if you look into this product table, this product table is having ID, right? And now we have another table wherein we are mapping like this order number, total item number, this is the product ID, this is the quantity, right? How do we identify that for 1000 order number, how many quantity are there and which product is there? So this relationship has been created with the order table and the product table, right? So this way we create relationship between the tables. So relationship, through relationships, if you see that we can connect the tables, we connect the relationship between the tables, and also these tables are in more managed form, more cleared form, right? So if suppose we are storing everything in one table, it would be really difficult to access the data, and it would be time consuming to access the data. So in this way, in normalized form, wherein we have some purpose of the table, based on that we are keeping the data, and in normalized form, not in that everything putting into one table. So this is helpful. Normalized data is helpful to remove the duplication of data values, and also it we are storing once and accessing by relating the data, right? So this way we are managing tables. So tables are managed, and querying the data, how we are querying using SQL, right? Structured query language. So that is a way to access the relational data. Okay, so next coming to non-relational data. So non-relational databases are databases wherein there is no relation between two tables, right? And these are referred to as NoSQL databases, even though we have some support of SQL language to access the data. But if you see that there is no support of, there is, these are kind of NoSQL databases. So they it's having total 4 types of ways to store the non-relational data. Let's cover one by one. So first is key value databases. Key value databases means wherein its key is unique, right? So 123, 162, 201, these are unique. We cannot enter duplicate keys. But along with the key, we are putting value. Like for example, if you look into these values, if suppose we have to manage this into the relational data, we can have 3 columns, right? Key, then a hammer, then a cost. But in this case, we have key value pair, right? With one key, we have one value. So this way, this is associated and unique keys are there. There is no such relation kind of thing in multiple tables, right? Second part is document database. Database is this one, customers. So if you see, this is overall a key value database, but value is stored in the JSON document. So if this is the key, this is unique key, and this is kind of JSON format, like name, email, these are the attributes, Joe, Jones, and if suppose we have contacts, we can have some objects under that as well. So this is kind of JSON format, and this is overall optimized to parse and query format kind of. Then based on key passed, then we can access this complete JSON and write the processing format along with accessing the JSON. So this way we use to process the data for document database. Third part is column family databases. Column family is kind of like columnar, which stores tabular data comprising rows and values, right? But you can divide the columns into groups. For example, it's having key, right? And this complete customer is in a group, right? Which is called as column family. Like customer is completely one column group, wherein it's having sub parts, name and address, this way. Similarly, product is group of complete column, wherein it's having for the name, price. So this way, these are logically related together. So based on that, it's stored in the database. So but otherwise there is no different tables and relation between that. Fourth is graph database. So graph database is like storing entities as node and with linking to define the relationship between them. For example, let's say Ben works in hardware, Sue works in hardware, right? And Ben reports to Sue. So this way, this is relationship created, but through this relationship is based on the nodes and linking between them. So next, coming to transactional data processing, which is very important. Reason is like in every organization or every like kind of work, always transaction needs to be always up to the mark. And let's take one example to understand the transactions. For example, say let's talk about bank. Suppose one person has to transfer data from one account to other account, right? So event is like there needs to be some event, right, to initiate the transaction. So for example, he has initiated transfer, so movement of money between accounts, like from one account, um, movement is initiated. So how it will happen, like from one account it will be deducted and from the other account, if you see it, it needs to be credited. So in between, suppose somehow some network glitches or something happens, it has been deducted from the account, existing account, but it's not added in the other account. So in that case, transaction failed. In that case, what will happen? It would be big mess. Reason is that transaction failed in between. So whatever transactions are happening, so we have to make sure either it needs to be complete or rollback, means nothing happened. Like if suppose in between some glitches happened, so it should be roll back the previous part. So transaction systems are generally high volume. Sometimes it handles millions or trillions of transactions in a single day. But data, whatever we are processing, that needs to be quick, fast to access, fast to process. Along with that, there we need to take care, like transaction needs to be complete always, either completely rollback or completely done. So to ensure this, we have to have some locks, some checks, some kind of processing checks needs to be there, right? So whenever we work with the transaction system, big transaction system, right, and we are accessing data and storing somewhere, such type of scenarios we call as online transaction processing, right? So OLTP solutions generally rely on the how optimized data storage is and how optimized its read and write operation to support the high transactions to ensure that it's completely done or it's not done, right? So not in between state, so that ensure this can happen only through some acid properties, or maybe we can say acid semantics. So acid is nothing but atomicity, consistency, isolation, and durability. So these are the four properties of acid. All changes which are performed on the data, they are single operation, like whether we are performing into multiple accounts, multiple tables, but that needs to be single operation, like either done or not done, right? So all the changes has to be like transacted properly. So let's go into every property one by one. So atomicity, what is atomicity? It says that each transaction is treated as a single unit which success completely or fails completely. Like for example, I have just given one example to take amount from one account and pass it to other account, right? So in this two parts, these two sub transactions need to be taken as one complete unit. And if suppose from one account it has been taken but not added in the other account, then it would be complete failure, right? And it's financial failure. So in that case, so we should have some transaction start, and in between if some glitches happen, then roll back entire transaction. Or maybe if complete both the parts is completed, then commit that transaction. Somehow there should be some start and commit, right? And in between if some mess is happening, then completely roll back. So this needs to be taken care. So atomicity means take this two parts or three parts of transaction as a single entity, single unit, so that either it will be completed or failed. Second part is consistency. Transactions can only take the data in the database from one valid state to another state. So database is initially in a consistent state, and that should be taken care even after transaction as well, right? So data needs to be consistent even after transaction. So that need to ensure. Third point is isolation. Concurrent transaction cannot interfere with one another and must result in a consistent database state. For example, like if one in the backend, if suppose we are taking data from one table to another table, right? So there are maybe if suppose multiple transactions are having millions of transactions are happening every day, in that case there may be possibility of concurrent transactions. So if suppose from one transaction one, if that transaction is putting some data and transaction 2 is taking data out of that table, it should not interfere each other transaction, right? So every transaction needs to be taken care separately and it needs to be consistent in the database. So multiple transactions whatever are running concurrently, it should not affect each other, right? So that is important. So transactions whatever running concurrency need to be maintained, and transaction needs to be consistent in that case as well. Fourth part is durability. When a transaction has been committed, it will remain committed. It does not mean that after 10 minutes, 15 minutes, it roll back. No. So that should be committed. So changes that have been committed to the database should remain even in the case of software failure or system failure as well. So that needs to taken care. So in that case only transaction can be successful. And in big organization, whenever we have lots of transactions, so in that case only reliability would be there. So OLTP systems are typically used to support live applications that process business data. It can be line of business application. It can be any kind of financial data or maybe credit card related data, bank data, right? And it can be any type of data. So next topic is analytical data processing. So analytical data processing typically uses read only or read only system or read mostly system. Most of the time reading the data, and it stored vast volume of data, vast volume of historical data or maybe business related data. Some metrics need to calculate. In that case we used to store the data. So analytics, in analytics majorly we are using snapshot of data, which is nothing but readable read only kind of data, and this is used to identify some metrics or to do some analysis on the top of that. That's the reason we generally use this. So let's look into this solution, this data processing solution. And if we see that analytic processing system can vary based on new solutions, like for fast processing, for fast accessing of data, right? So we provide different solutions. But common architecture, if you look into, that is the this is the common architecture. Let's cover that. We can have data into different storage, like it can be database, it can be file format, right? So this is overall data. And this first point I indicated as the central data lake, right? So data files, whatever, either database or data file document, these are stored in the data lake, right? So one is the data lake, this is for the storage perspective used. Then second point, which is a major point in the overall solution, is the this is data warehouse, right? So we all know about extract, transform, and load process. Extract from the data lake, then transform it and load it into the data warehouse, right? Or copy the data into the data warehouse. So this is called as ETL process, right? This is to optimize the data for read activity. And commonly data warehouse schema is based on the this is based on fact and dimension tables. Fact table, which contains numeric values and which is used to analyze the data, like for example sales data, right? So and related dimensions table, which represents the entities by which you want to measure them, like customer or product data. So generally in data warehouse we store data into the fact and dimensions tables. So data in the data warehouse, it may be aggregated based on the metrics we require in the analytics perspective, right? So aggregated values we can have, like for example, we need to check how many sales data we have, for how many sales we have in a month, right? That aggregated data we can have in the data warehouse. That aggregation we do in data warehouse, and can and that aggregation or calculation is helpful to show the data directly for the metrics analysis perspective, right? So if you see, data in the data warehouse may be aggregated and loaded into an online transaction processing system, right? Online analytical processing system, and which is nothing but the cube for fast processing perspective. So whatever aggregation we have done for numeric values from fact tables, and these are calculated for intersection of dimensions from the dimensions table. Like for example, we want to find sales revenue, or maybe we have to find the overall cost of products, right? So data in the data lake is passed to data warehouse, wherein we can have some calculated data, and that calculated data can be kept into the cubes, right? And from the cubes we are accessing data into the reporting format. Maybe it's a Power BI reports, wherein we can have some visualization dashboard, and on the top of that we can have analysis of the data, wherein we can look into the overall metrics analysis, and further can be used for the prediction model, right? So if you see that overall data lakes are common in modern data analytic processing scenarios. Everywhere we are using large volume of file based data or databases we can store in data lake. Data warehouse is established way to store the data in relational schema, and this is optimized for read operation, wherein we can have large amount of data to support reporting and visualization part. So in data warehouse schema we have data into fact dimensions tables, and it may require sometimes denormalization data in OLTP data source, and that is why that is required just to for the fast processing perspective. Then we can have some data aggregation into the queue. Data aggregation is required for the to show the data into drill down format in the Power BI reports, or maybe some other reporting tool we can use, right? And that is helpful to identify the metrics. So different types of users might perform data analytics work at different stages. Like for example, data scientists, they access the data for doing some prediction. On the top of that data, they take data from the cubes or data warehouse, and then start doing some predictions on the top of that for the business perspective. Another category can be data analyst, which may query the data based on their requirement, and can analyze the complex reports, and can look into how their business is growing, right? And third type of users can be business users who consume the pre-aggregated data that is also required for the analytic perspective for reports or dashboards. So this way, three different types of users can access the data. for a business perspective to understand the overall growth of the business. So this is all we covered in the first module. Hope this video is helpful for you.